I kind of want to pick up where we left off yesterday, but I want to have a bit of a departure. Yesterday, by the end of the class, we had kind of satisfied this idea that there are mathematical models that can be used to kind of sidestep having to do graphs. And this is one of the mathematical models that we got from yesterday. We also got this mathematical model, and we developed this from the area. And now those represented our two mathematical models that potentially could be used to solve any of the questions that are presented to us. Now, I say this because you guys are students of algebra. You've had some experience with algebra. If you look closely here, you'll notice there's 5 different things being associated together here. And each one of these relationships has 4 of those things in it. Can you see that, or do I need to spell it out for you? How about I spell it out for you? I see V and V naught. Those are both represented here. They're different variables and they have specific meanings. You should be aware and have their definitions. But if not, let's kind of spell it out. This one is the final velocity. This one is the initial velocity. They're both velocities, so they're both about how fast something is going, but they are vector quantities. Both of these relationships also have time in it. Time is a scalar quantity. I don't put the bar on top of the time. And I have delta x in one of them, which is defined as displacement. I made a big stink about this yesterday, about the difference between displacement and distance. I want you to be very aware that it's intentional to trick you by asking for one versus the other. So don't be surprised if your test asks for one and not the other on purpose to see if you know the difference. Asking for both is just mean, but they'll do it, right? Do you understand why asking for both is mean? Because if you get one wrong, you're going to get them both wrong. All I need to do is ask for one to know whether you know the distinction. But know the distinction. An important difference between displacement and distance is that displacement shows up in these equations. Distance doesn't. Okay? So if you want to find distance, you're going to have to do more work for it. Last is acceleration. Now, all of these have... So there were some in there. Yay! Well, Nathan, he probably wanted his card. Yay! So, in addition to knowing that, I think it's not a bad idea that you also know the units associated with them. Every one of these problems yields information. And one of the things you can do with the information given is sort it out. And one way to sort it out is just to look at the units that are being given to you. Right? You don't really have to do that much work. The only time you might have to work for it is if you're having to choose between initial velocity and final velocity. Right? But they're going to give you a value, and they're going to give you the value in its units. So these problems are not particularly interesting once you get past the fact that they just become plug and chug outside of all the graphing. The graphing was provided as a means to demonstrate where this stuff comes from. But once you understand where it comes from, these problems really don't do very much for us, and they're not very interesting. I want to kind of demonstrate that right now with the problem that's just been given to us. If we look at what was given in that problem, that a sprinter runs 100 meters in 10 seconds, starting from rest, they're providing us with 3 of these pieces of information. If we look at what they said, and I'm not going to put the problem back up, but you guys know what the problem is, or at least have seen it. So, based on what the problem asks, The sprinter started from rest. Pay attention to words like that. Starting from rest means its initial velocity is 0. Initial velocity is the velocity at the start of some observable period. So I'm giving you more information about these definitions because sometimes a problem might need to be broken up into multiple parts. And initial doesn't mean the very beginning every time. It means the start of your observable period. Like one of the problems has you throw a ball up into the air. Well, I could ask about the trip up. I could also ask about the trip down. Well, you might want to break the problem up into 2 parts. Initial is the start of the part you're observing, not the beginning of every problem. Final is similar. Final is at the end of the observable period. So time is associated with the beginning and end of that observable period. So at time equals 0, the sprinter had a velocity of 0. And then at time equals 10 seconds, they gave us an observable period. The sprinter had traveled 100 meters. I can place most of these just by knowing their units. Now, I hope this part is not me stating the obvious, but if you look at this relationship, which was built on the foundation of slope for a velocity versus time graph, you'll notice it has 4 of the motion variables in it, but doesn't have displacement. That means that relationship can't be used to solve for displacement, obviously. But it also means if you've been given displacement, it's not a whole lot of use to use that relationship. Similarly here, this relationship has everything in it except for acceleration. That means that it can't be used to find acceleration, but also means if you've been given acceleration, it's of no use to you. Now, here's the thing I do want the smart people to kind of think about. All of these problems are going to be based on trying to use these relationships. All of these relationships have 4 things in them, suggesting that you have to be given 3 pieces of information to solve these problems. If that's not obvious, then let me make it obvious. The only way to solve any one of these problems is to be given 3 pieces of information. If you're not given 3 pieces of information, there's a piece that's there, it's just hidden, and you need to look harder. Every one of these problems will have 3 pieces of information given to you or they are unsolvable. Now, those 3 pieces might be spread across both of these relationships. That might make it harder to solve, but not impossible. You guys are sharp people, you can figure it out. But I'm gonna point out that I think I can use this one to figure out one of the unknown pieces of information. I don't wanna look at a graph or anything like that. We can, but we don't have to. If I look closely at that one, my delta x is 100. My initial velocity is 0. My time is 10. If I trust that the model can tell me things, the model can figure out what this answer is. Now, I could have drawn the graph and I could have recognized it's a triangle and I could have done a triangle area and stuff, but I want to propose to you that the model is probably a faster way to do this. And here's where you break out your calculator and you do some fancy math and you figure out that the answer is what, 20? Well, now that I have another piece of information, could probably use this to figure out what the acceleration was. And I have all the pieces necessary to do so. So 20 equals a times 10 plus 0. So a has to be 2. What do you think? Is this a problem? You gonna be okay with this? Can you do them all now? I would hope so. Now, I'm gonna try and expand on this, but why don't you take a minute and do the next one? Because if you haven't attempted it, there's not a trick here, but there is some assumptions that have to be made. Pay attention to the things I had said earlier about what's the start of the interval, what's the end of the interval, stuff like that. I'm going to take back over because that should be done. And if it's not, then perhaps you've reached an impasse and you need to get past it. Okay? So let's see if we can see where your impasse is. The ball was thrown from the ground upwards at 40 meters per second. I'm going to assume that this is the start of our interval, And the initial velocity of the ball is 40 meters per second. We're trying to find out how high the ball went, the maximum height attained by the ball. I think we know how fast the ball is going at its maximum height. It's not stated in the problem, but I think the maximum height has to be when the velocity is 0. Because if it was still moving upwards, this wouldn't be the maximum height. And if it was moving downwards, it would have left its maximum height. The maximum height has to be when it comes to rest for that second, that brief moment in time before it returns to the ground. Does that make sense to all of you? So I had to interpret that from the problem. It wasn't told to me. And I'm going to expect that you guys can make interpretations like that. They told us something else, though. They told us that the ball has an acceleration of 10 meters per second due to gravity. I'm going to add something to your list of to-dos. Obviously, I need you to sort the information that you've been given as best as possible. But every one of those symbols that has a bar on top is a vector. And one of the things that you will have to begin to do is make decisions about vectors. Vectors have direction. And for right now, one-dimensional motion, direction is positive or negative. So you will have to decide whether upwards is going to be positive or upwards is going to be negative. The decision doesn't matter. It's arbitrary, but you have to decide one or the other. So do you want upwards to be positive or upwards to be negative? Okay, so upwards is positive. That means anything that's upwards is positive. But gravity acts to pull things downwards, right? So I'm going to make the gravity negative. You need to be intentional about direction. If I can say nothing about what will make your next test the most challenging thing, it's about not being intentional about direction and your problem's not making any sense. Please be intentional. Take a moment and decide what direction you'll call positive. Draw it on a picture, something to help you and help your test grader know. Because one of the questions on some of your FRQs I will say to you, did the person choose positive or negative correctly? It'll be worth a point. Having a picture with something drawn that shows you what direction you have decided is positive is a way to tell your test grader that you were intentional about direction. So I will encourage you to do that. Now, when I look across this, I'm going to notice that I have enough information to find the time. I think that's probably where I'm going to go first. I can't find the height directly, but I can find the time directly. You guys see that? So I want to do that first. That's not going to be too hard. 0 equals negative 10t plus 40. And if you were here for tutoring this morning, I also brought out the fact that acceleration is how much the velocity changes. In the first second, the velocity goes from 40 to 30, right? That's what acceleration is. It's the change of velocity per unit time. And the acceleration says that I take away 10 meters per second every second. So I could probably figure out that this would have taken 4 seconds to do. But again, we have tools at our disposal. Now, once I have found the time, I'm pretty sure I can find out the displacement. I can put this in here with the other information that's given, find out that it's 80 meters. Now, here's the thing I want to suggest to you. This is a 2-step problem to find out how high the ball went. Doesn't have to be. You guys are smart, but I don't think that you guys always see the potential of creating something new. I don't want to always have to do 2 steps if I can avoid it. If you look at what we actually did, we solved for t in one relationship and plugged it into the other. The power of algebra, the reason you were taught algebra, is that we could do that one time and never have to do it again. Meaning, rather than put in numbers, I could solve this relationship for time. If I do so, I get v minus v naught over a. And I can plug that into this relationship. If I do this one time, I create a new relationship that does not have time in it that I could use to solve the problem they were just given in one step. Right? Because I've eliminated time now. I was given acceleration, initial velocity, and final velocity. I could use it to directly solve for delta x. Doing this problem once now works every single time I'm given that combination of things. Now, this doesn't look like it's easier to work with, but I know algebra. Do you know algebra? This actually can be cleaned up quite nice. I would encourage you to consider how to do so. Since this is the first time you've done stuff like this, I'm going to help you out. First thing I'm going to do is realize that I have a 2 and an a in the denominator. I'm just going to pull those out front, and what I'm left with is v naught plus v and v minus v naught. Now, you guys are generally smart, but you don't always see the forest for the trees. If I move, I can add in any order that I want, so I could just switch those two. And does this look familiar to you? Right, this is a binomial expansion, so I could turn this into the difference of squares, or I could use the distributive property and show that it becomes the difference of squares. If you don't know that, I'd like you to know that because it makes you a better algebra student. And then I can multiply both sides by 2a. That way I get rid of the fraction. This is a new relationship, and it exists because I combined the other two. It has 4 things in it, but it's missing time. Now, if you're really kind of seeing where this is going, this one misses delta x, this one misses acceleration, this one misses time. You recognize there's 2 more here, right? One of them's going to be missing final velocity, and one of them's going to be missing initial velocity. You could find these things. You could do the substitution and put them in there. I would encourage you to be able to do so. That's a job that I forced the mechanics students to do. I'm not going to force you guys to do it, because as an exercise goes, it doesn't really have very much practical usefulness for this class. But this is the full run of the 5 motion equations. These are called Galileo's motions equations. They solve all of these problems in a single step. I would encourage you to have these on a note card for the next couple of days. I would encourage you to have the list of variables and their variable names, and I would have their associated units with them. I'll allow all of that to be on a note card. I would encourage you to make that note card and have it available to you, especially tomorrow, so you can use it on your first quiz. So tomorrow, if you have a note card, you may use your note card, not your neighbor's note card. Does everybody understand? Now, if you're looking at this, be careful. The negative signs, get them right. You understand that if you put the negative sign in the wrong spot here in one of these equations, you're in trouble, right? So I would encourage you to carefully write them out, make sure they are correct, verify them against what's up there. So I've just rewritten them here, but I've arranged them a little different because I've arranged them so that whatever variable is missing, I've put it across from the equation that doesn't have it in there. Because I said to you earlier this year that sometimes people take classes and they take them before they're ready. And there might be somebody in a room like this, and so I'm going to help that person out by giving them a crutch. A way of maybe getting what they need out of this without having to do as much thinking. So we're going to do the last problem, the mountain goat problem, real quick. Again, I'm not graphing it right now, but I want you to consider the mountain goat problem for a minute. The mountain goat knocked off some rocks that slid down the slope, taking 5 seconds to go 100 meters. Does that make sense? Am I reading it correctly? So the mountain, something like this, the rock started here and tumbled until it was down here at some velocity, which is 100 meters below where it started. I'm going to make this way the positive direction. Okay? My displacement is 100 meters. My initial velocity for the rocks is 0, and the time it takes the rocks to make it down there is 5 seconds. This is the information given. If you want to solve a motion problem, and you don't want to think very much about it, you can use this rubric to do so. And we'll look closely. I wasn't given the final velocity, but I was asked to find the final velocity. Does that make sense? So I wasn't given this, and I wasn't asked it. But I also wasn't given the acceleration. So if I'm trying to find the final velocity, and I don't have the acceleration, whatever equation is over there is going to do it for me in a single step. Right? 'Cause I'm missing a piece of information. So I take the equation that doesn't use that piece of information, but has in it something I want. So if you have them organized like this, it'll help you narrow down which relationship is the one that you should use the most expediently. Knowing that means I can start with that relationship immediately and get to my answer. You'll solve it in one step. I can reverse that too. Let's say I didn't do it that way. Let's say I wanted to find the acceleration first and didn't have the final velocity. Well, that means this relationship is the one that will give me the acceleration without having to have found the final velocity. Everything should fit in there someplace, leaving me with one unknown. Let's see if it does. 100 equals 1/2 times a times 5 squared plus 0 times 5. Yep, looks like it'll do it in a single step. Everybody follow along okay? I want to do more. The worksheet was just a crutch. It was a way to get us to go from graphs to dealing with these kinds of problems. So I want to turn these up and make them a little more challenging, but I want to see if you're capable first. So this isn't a quiz, and we're on an augmented schedule, so I gotta see what kind of time I've got. I have 10 minutes. So I'm going to create a situation for you. I want to see what you guys are capable of doing, okay? All right. Student drops the ball from the top of his house to his friend below. So student here, ball, friend. That is a perfect representation, right? 4 meters. I want to know how fast is the ball going just before the friend catches it, and how long does the ball spend in the air? Don't need no stinking graphs. This is what I want. There are 8. Answer's about 9 meters per second and about a second in the air. It'll depend on where you rounded for your actual answers. Let's see if we can kind of put this together real quick, okay? I'm going to start, and I'm going to start every one of these problems in a similar way by listing out the motion variables. I would encourage you to come up with a way to do this, but this is the framework that I'm going to use. I'll list the motion variables, I'll see what motion variables are given, and then I'll decide on a course of action. So my first step is to see what was given. The ball falls 4 meters. It's dropped. That means starts from rest. And I know that the acceleration of gravity is 10 meters per second because they told me that gravity was acting on the ball and they gave me the size of gravity. So listing out what I have, I can sort all of these just by their units. Next, I have to be intentional about direction. Do I up to be positive or down to be positive? Okay, if up is positive, then the ball fell downwards 4 meters and was being pulled downwards by gravity at 10 meters per second. Right? So if we choose up to be positive, we have to be intentional about direction for the other things that are vectors. Any question about that? I need both of these things that are missing. So I want to choose a relationship that can get to it in a single step. I'm pretty sure to get velocity, this will solve for the velocity in a single step. It has all the things in it that I'm looking for and have been given. It doesn't have time in it, but I wasn't given time, and I'm solving for velocity first. Any question about why I started here? So 2 times -10 times -4 equals v squared minus 0 squared. Answer is going to be plus or minus the square root of 80, which is about 9. Plus or minus is important, though. What's the actual answer? Is it positive square root of 80 or negative square root of 80? Should be negative. So about -9 meters per second. Or if you'd like, don't put the negative sign and say downward. We are intentional about direction. This one, because of the plus or minus, you have to be intentional. When you take the square root, you have to ask plus or minus. All right, halfway there. I need to use a relationship that doesn't have final velocity in it. I think I got one. Does that look good to you guys? I will, -4 equals 1/2 times -10 t squared plus 0. Looks like t is going to be the square root of 0.8. Now, for time, it's always the positive answer. All right. Always the positive answer.